Welcome to this explainer. I'm so glad you're here because today we are jumping right into a topic that's honestly a little mind-blowing. We're talking about beta-glucans in integrative oncology. You hear this term tossed around a lot in natural health circles, but today we're cutting through all that noise. We're going to look strictly at the hard science, the cellular biology, the clinical trials, to figure out exactly how these natural compounds actually interact with your immune system.
Think about it. Can a complex sugar molecule actually help the body fight cancer? It sounds like total science fiction, doesn't it? But that question right there sets the stakes for what we're investigating today. We're not talking about some synthetic lab-created drug. We're talking about a natural compound found in everyday things. The idea that a fundamental sugar molecule could step up and modulate our immune defenses against some of the most evasive, stubborn cells in the human body? That's huge. So how in the world does that actually work?
Well, here's our roadmap for finding out. First, we'll cover what beta-glucans actually are. Then, we'll look at the immune system awakening, followed by the cellular battleground. After that, we'll dive into the clinical trials and evidence, and finally, wrap up with the sources, specifically mushrooms and yeast.
All right, let's kick things off with Section 1. What are beta-glucans? This is really the foundation of nutritional immunology, so let's get our baseline. So, biologically speaking, a beta-glucan is a complex sugar molecule, or, if we want to get technical, a polysaccharide. Basically, imagine a giant sugar molecule made up of a bunch of smaller ones linked together in this intricate chain. You'll find these chains woven right into the cell walls of fungi, yeast, and even grains like oats and barley. But here is the absolutely crucial thing you need to know right out of the gate. Beta-glucans are not toxic to cancer cells. They don't just roam around, find a tumor, and destroy it. No, their entire mechanism of action is focused on you, the host. They act as these incredibly powerful stimulants for your immune system.
In fact, if you read the scientific literature, you're going to see them called biological response modifiers. And I love that phrase because it hits the nail right on the head. They are literally modifying your biology to respond better to threats. They take the immune defenses you already have and they optimize them. It's like upgrading your immune system software so it works smarter and harder. And why is that a big deal? Because it means you're handing your body the exact tools it needs to fight its own battles. By cranking up the production of vital antibodies, beta-glucans help your body mount a massive response to foreign invaders, whether that happens to be a virus, bacteria, or a rogue tumor cell.
Which brings us to Section 2, the immune system awakening. Let's trace the actual journey of this molecule inside your body.
So the journey starts the moment you swallow it. When you consume a highly purified beta-glucan, it actually survives the incredibly harsh, acidic environment of your stomach. The real magic? That happens in step 2, when it hits the small intestine. It dissolves right there, which allows it to cross over into the lymphatic system. And you can think of the lymphatic system as the superhighway of your body's immune network. Once it's cruising on that highway, it enters the bloodstream where it gets to work on its main job, binding to and priming your immune cells, specifically the neutrophils.
Now this is where it gets absolutely fascinating. It's all about unmasking. See, cancer is notoriously good at hiding, right? Neutrophils make up roughly 50 to 60% of your immune cells, but normally they just float right past cancer cells without recognizing them as a threat. But when that beta-glucan binds to the outside of a neutrophil, it primes it. It's basically handing that immune cell a biological wanted poster. Suddenly, the neutrophil sees those sneaky cancer cells as a foreign fungus. It completely unmasks the threat, giving your immune system the green light to attack.
Moving on to Section 3, the cellular battleground, receptors and reactions. Let's zoom in on the specific cells joining this fight.
We just talked about neutrophils. They're the foot soldiers, the bulk of your immune forces, but they are definitely not fighting alone here. The research shows these complex sugars wake up an entire army. They crank up the activity of natural killer cells, which are essentially your immune system's specialized assassins. They bring in the macrophages, which act like microscopic garbage disposals, literally engulfing and digesting cellular debris. And they stimulate helper T cells to coordinate the whole attack. You are basically putting your entire defensive line on maximum high alert. But how exactly does this molecule sound the alarm? Well, the science points to a very specific physical connection. Beta-glucans trigger this whole response by docking into a specific membrane receptor on these immune cells called complement receptor type 3, or CR3. Sometimes you'll see it called CD11b. Just think of the beta-glucan molecule as a highly specific, customized key, and the CR3 receptor is the lock.
When that key slides perfectly into the lock, it sets off this massive chain reaction inside the cell, waking it up and triggering that aggressive tumor-fighting behavior.
And this highlights something even more exciting: synergistic potential. Researchers are discovering that beta-glucans don't just work in a vacuum. They can actually make conventional therapies perform better. Preclinical models, and we're talking about studies from places like Memorial Sloan Kettering Cancer Center, have shown that targeted monoclonal antibodies are actually more effective at killing tumors when paired with beta-glucans. The beta-glucan literally boosts the white blood cell's ability to destroy the tumor cells that the antibody drug just targeted. This is a massive game changer, guys, because it implies that these natural compounds could take our most advanced lab-made treatments and supercharge them.
Let's jump to Section 4, Clinical Trials and Evidence, from lab to patient. And just a quick note, we are looking strictly at documented research here, not giving medical advice.
When you actually look at the trial data, the results are super interesting. Over in Japan, they've extensively studied lentinim, which is a specific beta-glucan derived from shiitake mushrooms. Multi-center trials showed that when they used it alongside chemotherapy for gastric cancer, it seemed to prolong patients' lives and really improve their sleep and appetite. Then you have Memorial Sloan Kettering evaluating beta-glucans paired with the drug rituximab for lymphoma and leukemia patients. And in a completely different study, breast cancer patients who took a small daily amount of nutritional yeast-derived beta-glucans saw a 50% spike in their monocytes, a key white blood cell, after just 2 weeks.
So what is the clinical consensus on all this data? Across the board in the literature, beta-glucans are primarily viewed as adjuvants. All that means is they are complementary treatments. They're meant to be used right alongside conventional strategies like chemo or radiation. The ultimate goal is to boost overall survival rates and, just as importantly, help soften the really harsh side effects of standard treatments. Plus, the sources consistently point out that, aside from a few rare allergic reactions, major complications or organ toxicity just haven't been reported with this family of compounds. They have an incredibly favorable safety profile.
All right, our final section, number 5, sources, mushrooms, and yeast. Where exactly do we get these things? Let's take a look.
The scientific literature mainly highlights 2 natural origins for extracting beta-glucans: mushrooms and yeast. On the mushroom side, you have tons of research on extracts from maitake, shiitake, and agaricus blazei mushrooms, all of which have this deep history in traditional Asian medicine. And then on the flip side, you have yeast-derived beta-glucans. These are pulled straight from the cell walls of everyday baker's yeast or nutritional yeast. Yes, the exact same yeast that makes a loaf of bread rise is right in the middle of a modern oncology debate. Both sources are packed with these vital sugars, but there's definitely some back and forth in the integrative oncology space about which one is actually better for therapeutic use.
And that brings us to the solubility debate. A prominent voice in our sources, author Bill Henderson, makes a very specific argument for yeast-derived beta-1,3-D-glucan. He claims that a lot of mushroom-based glucans are highly soluble, making them really hard to control as they move through your digestive tract. But he argues that a properly encapsulated yeast-derived product will survive the stomach perfectly and dissolve exactly where it needs to, in the small intestine. According to Henderson, this precise, targeted dissolution is the key to maximizing how much of the compound enters the lymphatic system, which in turn optimizes that all-important immune response.
Which leaves us with a pretty profound final thought to chew on. We are looking at an ancient, totally natural compound, complex sugars found in simple fungi and yeast, that is now the focus of intense, modern clinical research mapping exact cellular receptor sites. As we keep uncovering how these biological response modifiers can synergize with conventional treatments while actually protecting a patient's well-being, how might beta-glucans completely reshape the future of integrative oncology? It's a fast-moving field, and honestly, it just reminds us of how incredibly complex and brilliant the human immune system really is. Thank you so much for joining me for this explainer. I really hope this deep dive gave you a much clearer picture of the science behind beta-glucans.